Okay, to start our lesson today, we're going to turn to the first page of 8.4. I know that we've done this page already, but just as a quick review, I wanted to look again at the equation for sinusoidal function, or the sine function, and just talk about each of these parameters again, just to review them so that you remember what happens when we monkey around a little bit with the regular sine function. That we know the characteristics of the sine function are that it has a period is 2 pi, its max and minimum points, maximum point would be 1, minimum point would be -1. It always starts at the origin, so it starts at 0, and so the amplitude of this function, the distance from the midline to the maximum point or the midline to the minimum point would be 1. These are the basic characteristics of the regular sine function. But sometimes we have some other parameters that are included. And so when we have put a number that we're multiplying sine by, the a, this is going to affect your amplitude. So if a is 3, it means your graph is going to be 3 times the height that it normally would be. So instead of an amplitude of 1, it would have an amplitude of 3, okay? So really it's a vertical stretch. If we play with the parameter b, this is not your period, but it affects the period. And do you remember those two formulas for figuring out what b is? B is 2 pi over the period, if you know what your period is, or if you just flip-flop these two numbers around, if you knew your period, or sorry, you knew b, but you wanted to figure out your period, it would be period equals 2 pi over b, okay? Then, remember, if we add or subtract a number from x, in other words, we're changing our x coordinate by adding to it or subtracting from it, this is a horizontal shift, and it will always be opposite to whatever this sign is. So if it's a positive c that we're adding, this is going to shift left, opposite to what you would expect. And if we're subtracting some value, x minus some value, then it would shift right, opposite to what you would expect. Okay, and the last one, if we add or subtract some number out here, the d, then that is actually your midline. D is your midline, and it's just like you would expect. If you're adding d, it's going to shift your whole graph up. And if you're subtracting d, it's going to shift your whole graph down. Okay, so hopefully as we reviewed that today, you were like, oh yes, I remember that. I'm starting to kind of get a real handle on this, because you need to know this very, very well. So that kind of mind map that we made the other day on the plain sheet in your booklet, I really spent some time studying that and making sure that you know the effect that each of those parameters has on the equation. Okay, so yesterday we left off on page 18, so if you could turn there, please. Okay, and we left off, we did A and B, and then I left you with C, and we added a D to it. So let's have a look and see how you did with those. First of all, C, we have an A, we have a B, we have a C, but we don't have a D in this case. So there's no D, so that means there's no vertical shift or vertical translation. Okay. If our A is 2, that means our amplitude is 2. If our B is 4, so 4 times x, that means that we can figure out our period then. So period would be 2 pi over b, and our b is 4. So that means divide 2 from the numerator and 2 from the denominator. That would be pi over 2. And if our c is negative 45, that's a horizontal shift. And remember, it's opposite to what this sign looks like, what you would expect. So it's 45 degrees to the right. All right. And then I hope you also figured out your maximum and minimum points. So remember that maximum point is just the distance from your D, which is your midline, to your, and then you're adding your amplitude on it to get your maximum point. So D plus A in this case would be 0 plus 2. So maximum point is at 2. Your minimum point would be your midline minus your amplitude. And so it would be 0 minus 2. So your minimum point would be negative 2. So in that case, then the range of this function, if you graphed it, would be describing y such that y goes from negative 2 to positive 2. Remember, you're putting your y in the middle. It's a less than or equal to sign in both cases, and then close your bracket. So what that's really saying, if you read it from the y this way, you're saying y is greater than or equal to negative 2. And if you go from the y this way, y is less than or equal to 2. Y is right in the middle between negative 2 and positive 2. Okay, and then the last one that I left you with was seeing if you could do that exact same thing with just the basic sine function. So this was your d, and it was y equals sine x. Okay, so let's see if we can define what a, b, c, and d would be. So in this case, our a is 1. I hope you got that. If there's nothing in front, it's like 1 times sine x. So that means our amplitude is 1. Our b is, well, b is the number we multiply in front of x, right? So b again is 1. So what that means is the period then would be 2 pi over b, and if my b is 1, then the period is 2 pi. Well, that makes sense, because we know a basic sine function has amplitude 1, and its period is 2 pi. So far it's making sense. C, well, we don't have anything that we're adding or subtracting here, so it's really a 0, isn't it? So C is 0, so this means there's no horizontal shift or horizontal translation. It's not moving it horizontally left or right. It's the regular sine function, right? And then the midline, well, we're not adding anything. This part would be in brackets. We're not adding anything out here to the whole function. So d is 0, which means that our midline is 0. And there's no vertical translation or vertical shift. Okay, it's not moving it up or down. Okay, so this graph would be your regular sine function that starts at 0. It goes up, down, so up to positive 1, down to negative 1, and it has a period of 2 pi or 360 degrees if you're measuring in degrees, right? Okay, so this is exactly what we expected this graph to be. Okay, let's see if we can figure out our maximum. Max point would be d plus a, your midline plus your amplitude. So if my midline is 0, my amplitude is 1, my maximum point is 1, yes it is, right there, and my minimum point would be my midline minus my amplitude, so that's 0 minus 1, so my minimum point would be at negative 1, and yes it is. Okay. So hopefully you knew you were right because you got the basic characteristics of the regular basic sine function. Y equals sine x. All right, so let's go on to the next page then and see what does this mean in terms of like if we were to apply this now to a situation, how can we model data using a sine function? Okay, well, as we know, before we flip the page, a sine function is a periodic function. That means that this section of the graph is going to repeat over and over and over again, infinitely. Okay, it repeats on this side of the x-axis as well. It would repeat in both directions forever. Okay, now we're going to just concern ourselves with one period of this function. Okay, so we're just concerning ourselves with this red function. Okay, and remember we said if it has a period of 2 pi, then this point right here in the middle would be 1 pi. This is 0. This is where the graph is beginning. Okay, what's that point halfway between 0 and 1 pi? It would be pi, half of pi, right? Which half times pi, it's really pi over 1. So that's pi over 2, isn't it? So this point here in the middle is pi over 2. This point is really pi, which is 2 pi over 2. Okay, making sense now? You're realizing then that this would cancel out and we'd be left just with pi. That's how we got that. Okay, so if this is 1 pi over 2, this is 2 pi's over 2, what would this point be? 3 pi over 2, yes. I hope you got that. And then of course this 2 pi is the same thing as saying 4 pi over 2, which if you divided the 2 in the numerator and denominator, you'd have 2 pi, right? And that's how we got this number right here. Okay, so in fact, what we have really shown on this graph with one period of the sine function is the same thing as if we had shown it on a circle going from 0 or 2 pi. Okay. This position is 0 or 2 pi. Okay, and rotating this position then halfway around, if this is 2 pi, you go halfway around, it's 1 pi. So the position halfway to 1 pi is pi over 2. And then, so this is 1 pi over 2, 2 pi's over 2. This must be 3 pi's over 2, because this is 4 pi's over 2 right there, right? So do you see how this red section on the graph, one period of the sine function, is actually the same thing as if we started here on this, went to pi over 2, went to pi, went to 3 pi over 2, and came back around to 2 pi. Okay, we've started at 0, we've gone to pi over 2, we've gone to pi, we've gone to 3 pi over 2, and we've ended at 2 pi. Okay, so this is just the graphical demonstration of what's actually happening on this circle when you start at 0 and you go full circle around. Okay, one full rotation is the same thing as one period on the graph. Okay, 2 pi. All right, so on the other side then, we're going to talk a little bit about Ferris wheels. Okay, because a lot of the questions that simulate the sine function are often Ferris wheel questions, or because they have to be questions where something is repeating at a regular periodic interval, okay? Because the sine function is a periodic function. So it's something that's going to repeat over and over and over again, okay? So quite often you'll see that that's a Ferris wheel or a circle of some type, okay? Now, with Ferris wheel questions, or tire questions, because sometimes you're going to get questions about a tire that's rotating around and around and around. Just make yourself a note here. With Ferris wheel or tire questions, your A, your amplitude, is equal to the radius on the circle, okay? And that's kind of something that you just kind of need to remember. You will inevitably get a question like this on the diploma, okay? So remember that anytime you're talking about a circle or a tire or a Ferris wheel, your amplitude, the height of your graph, is the radius of the circle. okay? So Ashley boards the Ferris wheel at the Pacific National Exhibition. When the ride begins, her position can be modeled by the function y equals 43 sine 3.5 times x minus 0.9 plus 47. Okay, well, first of all, let's label each of our parameters here. So 43 would be our A, 3.5 is the B. Sometimes we see that 3.5 put with the bracket on this side instead of here. So if you want to switch it just so it looks a little more like the form that we've been using, that's fine either way. Your C is 0.9 and your D would be 47. Okay? And it says where Y represents the height in feet and X represents the time in meters. Okay, well, first of all, if A is our radius, then what would be our diameter? Because it says determine the diameter of the Ferris wheel. Okay, well, diameter is the full distance across a circle, right? So if this is my Ferris wheel and my amplitude is the radius, diameter would be, so this is my radius or my amplitude, then diameter is going to be 2 times that, right? Because you have to go all the way across. It's 2 radiuses. So if my radius is A, then it's just 2 of the amplitudes. Because the amplitudes are radii. I'm not sure what the plural form of radiuses is. Radii? 2 radii, right? Okay, and in that case then, the diameter would be 2 times 43, which is 86. And this is measuring in, it says, the height in feet, and the time is in minutes. Okay, so this would be 86 feet, the diameter of this Ferris wheel. Okay. What that means, if we graph this on as a sine function, you're going to get a graph that looks like this. Let's just write this over here in our margin. Okay. And so what's happening is you've got, well, you know what? We may need to figure out our maximum and minimum point first to do this. So let's do that. Our maximum point is going to be D plus A, right? So that means our midline plus our amplitude. Do we know what our midline is? Midline is your D, right? So 47 plus, we know our amplitude. Our amplitude is 43. So our maximum point is going to be 90. What's going to be our minimum point? D minus A. So that's going to be 47 minus 43. And so that's going to be 4 is our minimum point. So we've got a maximum at 90. I've got a maximum point at 90. I've got a minimum point at 4. And I've got a midline. That's the point that goes right through the middle between those 2 points. And that's at, I just calculated it here, 47, or I've read it off of my equation right here, 47. Okay, so what I've got is a graph now that instead of starting at 0, like most sine graphs do, this one has been shifted. It's got a vertical shift up of 47. And it's got a minimum point of 4. So instead of starting at 0 like it usually does, it's starting at 47 and it's going up to 90. It's coming down to negative, or to 4, I mean, and then back up to 47 again. Okay, so the distance here from my midline to the maximum, that's my amplitude, that's 43. And the distance from the midline to my minimum is also 43, right? And that 43 and 43 together makes 86, which is what this whole distance is from maximum to minimum. All right, let's see what the period is of this Ferris wheel. When it asks how long does it take for the Ferris wheel to complete one revolution, that's meaning what is the period, okay? So we know a formula for figuring that out. The period is equal to 2 pi over b, okay? So that's 2 pi over, what is our b? Well, we read that right off of our equation. B is 3.5. So if you calculate this on your calculator, 2 pi divided by 3.5, you'll get that it's about 1.8. And this is time in minutes. 1.8 minutes it takes to do one complete revolution, okay? It was telling us here that our x-axis represents the time. So that means the distance from here when the ride started till here when it did one complete revolution, one complete period, is 1.8 minutes. Okay, that's on our x-axis because x represents the time in minutes. Okay, and then y represents the height, right? And that's what we have going on our y-axis here, the height. Okay, so how high above the ground is actually at the lowest point? Okay, well, what is our minimum? We figured that out actually already right over here. This minimum that we figured out, that is the lowest point. Her lowest point is 4 feet. And you can see that from our graph. She is 4 feet above 0 at the minimum point on this graph. Okay, now you have a big empty space at the bottom of your page. That's because we're going to add another example. Okay? So will you label this one example 3? And I'm going to give you a graph. And we're actually just going to look at the section of it that is on the right of the y-axis. Okay? And this graph has a midpoint at 1. So label a spot here 1. And then this is going to be your midline. We'll show that with a dotted line. This graph has a maximum point of 3. So we need to go 1, 2, 3 on our y-axis. And it'll go down -1, -2, -3. Right. Now this graph is going to start at where y is 0. Your x is going to be 1, so it's going to start at 1. And it's going to go up to +3. Then it's going to come back down. Lowest point will be -1. Then back up to +3, like this. Okay? Now this point here, where the graph starts to repeat, this point here is pi. And this point here, right here, where it's repeated again, is 2 pi. Okay, now what I would like from you is number 1, determine the amplitude, period, and midline. And then the second part, and really the most important part, is now determine the equation of this graph. Okay, the whole reason that we've learned what the parameters A, B, C, and D do to the graph is because on the diploma they will give you a graph like this, where you'll just read the A or figure out the period or read the midline, and then have to be able to take that information from the graph and write it what the equation of that graph would have been. Okay, so determine the equation in the form y equals a sine bx plus d. Okay, so let's see if we can do this. Determine the amplitude. Okay, well, first of all, amplitude. Okay, sometimes you can just read it right off the graph. In this case, probably you can. We can see right here that the amplitude is the distance from midline to maximum point. Well, the distance from that, if that's 1 and this point is 3, the amplitude would be 2. Okay, but sometimes the graph is not that easy to tell. So let's get into the habit of using the formula. The formula for amplitude is max minus min all divided by 2, right? And so if you did that, you've got your maximum point, which is 3, minus your minimum point, which is -1, divided by 2. 3 minus -1 is 3 plus 1. 4 divided by 2 is 2. Okay, so your amplitude is A. Period is 2 pi over B. Problem is we don't see our B. So the formula maybe won't help us in this case. Can we tell just from looking at the graph? 1 period is 1 complete rotation, right? So from where the graph started, this one normally starts at the origin, but in this case it has a vertical shift. It's been shifted up 1. So 1 complete rotation is from where it ends right there, right? If you were to take that piece, that's where it would start all over again, right? Okay, so the period of this graph, we can actually just read it right off of there. I guess we really don't need this formula. So I will just erase the formula because we'll just say that the period is pi. Okay, and midline, we need the formula. Midline is, remember this is the one where we do need both, so it's going to be max plus min divided by 2. Okay, so maximum point again is 3, minimum point is -1, divided by 2. 3 plus -1 is 3 minus 1. 2 over 2 is 1. So the midline is 1. Again, on this graph, we can read that information right off of the graph. We probably didn't need to calculate it, but it's always a good idea to calculate it and make sure that what you're seeing and reading is you're reading accurately. And so that just kind of verifies what you saw on this graph. And like I said, not all graphs will be as simple and easy to read the information off of as this one is. Okay, okay, now that we have our amplitude, so we've got our A, we know the period, so we can figure out our B. We've got the midline, so we know our D. And our C is whether this graph has shifted left to right, but it hasn't, because it would have started here at the 0 if it were not shifted vertically. But it would have started here, and in this case, it's just a simple shift vertically when it starts here. There's been no horizontal shift, no left or right shift, right? Okay, so the equation then would be y equals, we need our A because we're doing it in this form, okay? So A is 2 sine, and then we need B. Well, we're going to have to figure out B because we know our period. So B is 2 pi over the period, which would be then 2 pi over pi. That's our period. Okay, so pi and pi is going to cancel each other out. Our B is 2. Okay, so what that means is we have 2x, and then our D is the midline. Midline is 1. Okay, so we've used the characteristics that we've seen in this graph to figure out amplitude, to figure out midline, to help us figure out what our B value is, and then we just plug that into the equation, and we can actually calculate or determine the equation of this graph. Okay, there is an assignment that you're going to do that goes along with what we've studied in this lesson. The assignment in your book on the next, I believe, 3 or even 4 pages in your book is the assignment, and then we'll have to do lesson 8.5 on Friday. Okay, so spend the rest of this class time working on that assignment. There is a Ferris wheel question in that assignment, just like this Ferris wheel question up here at the top. So while this is still fresh in your mind, would be a good time to tackle that assignment.